Well, this is section 11.4, and today we're going to do a little review. This first page is review, and then talk about some special polar graphs, plotting, and symmetry. And then in the next part of the lecture notes, I'll do a separate video for slopes and tangents. Since this first page is review, you might want to pause the video, go through it, and then start it up again and watch me go through it. All right, so when we're going from polar to rectangular, we want to use x is r cos theta and y is r sine theta. So in this case, we would have 2 cosine of 5 pi over 6 and 2 sine of 5 pi over 6. Cosine of 5 pi over 6 is negative root 3 over 2, so this will give us negative root 3. Sine of 5 pi over 6 is a half times 2 is 1. So our xy coordinates are negative root 3 comma 1. All right, going in the other direction, from polar to rectangular, first we're going to find r. And to do that, we're going to use r squared is x squared plus y squared. So in this case, that gives me r squared is negative 2 squared is 4, and 2 root 3 squared is 4 times 3, which is 12, so that's 16. So this gives me r is plus or minus 4. Now we're going to find two values of theta between 0 and 2 pi using tangent theta is y over x, which in this case is negative root 3. All right, so we want two angles whose tangent is negative root 3. So the slope's going to be negative and steep. That's going to be theta equals 2 pi over 3 and 5 pi over 3. All right, now to pair the thetas with the r's, we look at the quadrant that the point is in. The point is in quadrant 2. So if we choose the positive r, we need to choose the angle that's in quadrant 2, namely 2 pi over 3. If we choose the negative r, we need to choose the angle down here so that once we put the negative r on, we'll bounce up to the quadrant we want to be in. So those are our two answers. Convert r equals 2 to a Cartesian equation and graph. All right, if I had an r squared, I could replace it with an x squared plus y squared. So I'll just square both sides. And now I can replace r squared with x squared plus y squared. Remember, a Cartesian equation is rectangular. It's x's and y's versus polar, which is r's and thetas. Now that's a circle of radius 2, which we knew anyway, because r equals 2 is a circle of radius 2 centered at the origin. Okay. R equals negative 2 cosecant theta. So whenever r is some number times cosecant, that's going to be a y equals. Cosecant is 1 over sine, so multiply both sides by sine. R sine theta is negative 2. That's y equals negative 2. So that's a horizontal line going through negative 2 on the y-axis. All right, our last review problem. Okay, if I square both sides, I'll get a mess on the right-hand side, but if I multiply both sides by r, that'll be perfect, because on the left I'll have r squared, and on the right I'll have 2r cos theta plus 3r sine theta. Now I can replace the r squared with x squared plus y squared. I can replace r cos theta with x and r sine theta with y. 2x plus 3y. Now, this is a circle, so we're told to complete the square to find the center and radius of this circle. So let's move everything over to the left. Now I'm going to complete the square, and I just do this by inspection. I'm not using any formulas. I'm just saying, okay, how can I write x squared minus 2x as a binomial squared? Well, it's going to have to be x minus 1 squared in order to get x squared minus 2x. But that's going to give me an extra 1 that I don't have above. So I'll subtract that. Multiply that out. It's going to be the same as that. Do the same thing to this guy. This is y minus 3/2 quantity squared. But if I multiply that out, I'm going to have an extra 9/4 that is not in the original equation, so I better subtract 9/4. And that equals 0. Now just do a little cleanup. Get your constants on the right-hand side. X minus 1 squared plus y minus 3/2 squared equals 1 plus 9/4 is 13/4. So that's a circle. The radius is the square root of 13/2, because this is r squared. And then the center, a circle of radius r with center x naught, y naught, has the form x minus x naught squared, y minus y naught squared equals r squared. So my center, x naught, y naught, is 1, 3/2. Okay. Here are some special polar graphs that arise frequently when we do calculus with polar curves. We've got limacons and cardioids, roses, lemniscates, and circles. The only ones I want you to memorize are the circles. The rest you can use technology to graph. Circles come in 3 varieties. One, which I don't even have here, r equals a. That's a circle of radius a. And the period for this guy is 2 pi. If you want to get the whole circle, you have to go all the way around from theta equals 0 to 2 pi. But these other circles, a cos theta and a sine theta, they have period pi. You get the whole circle by just going from 0 to pi. Cosines are going to be oriented to the right of the y-axis or to the left of the y-axis. Left if a is negative, right if a is positive. And note a is not the radius, it's the diameter. And then the sine ones are oriented either above the x-axis or below. So let's see how that works with an actual example. So let's sketch this curve by plotting some points, and then we'll look for symmetry. Well, we know this is a circle because it's a sine theta. So we just have to figure out how it's oriented, and you can do that by just plotting some points. So I chose some values of theta. Note I only went to pi because the period is pi. So let's plug in these values of theta and see what r is. When theta is 0, r is 0. So let's plot that. That's here. When theta is pi over 4, sine of pi over 4 is 1 over root 2 times root 2. That would be 1. So to plot that point, I go to the angle pi over 4, that's here, and I go 1 unit out. So the coordinates of this point are 1, pi over 4 in polar coordinates. I have the theta first in my chart, but nonetheless, it's right here. All right, when theta is pi over 2, sine of pi over 2 is 1, so this is going to be root 2, which is about 1.4. So I go to the angle pi over 2, positive y-axis, and I go like 1.5 units out. All right, so we see now how the circle is oriented, but let's just finish up. At 3 pi over 4, sine is 1 over root 2, so we're at 1 again. So I go to the angle 3 pi over 4, and I go 1 unit out. And then when theta is pi, I'm back to 0. So just connect these points with a circle, and there it is. You have some questions in your homework about symmetry, and I suggest, well, I strongly suggest that you graph the curves first, then answer the symmetry questions. There are symmetry tests, which are at the end of your lecture notes, but we're not going to use them because they're cumbersome and they don't always work. Like, you can fail the symmetry tests and still have symmetry. I know, that's crazy. So we're just going to graph and look for symmetry from the graph. So is this curve symmetric with respect to the x-axis? No. If it were, it would have to mirror what it does above, below, and it doesn't. Symmetric with respect to the y-axis? Yes. And symmetric with respect to the origin? No. If x, y is on the curve, we'd have to have negative x, negative y on the curve, and that's not the case. Okay, so a number of your homework questions want you to sketch a polar curve, and I suggest in the, I put in the instructor tips, use Desmos. So let's just see how that works. R equals 1 plus cos theta. Let's go to Desmos and type in R equals 1 plus cos, and then just type in the word theta, T-H-E-T-A. And Desmos knows if you use R and theta, it automatically knows that you want a polar curve, not a rectangular curve. And the default is theta from 0 to 2 pi, but if you want, let's say theta just to go to 3 pi over 2, you can put that in. Or sometimes most polar curves have period 0 to 2 pi. Sometimes they'll have a larger period, like if this theta is divided by 2. Oh, that didn't do it. But anyway, what I'm trying to get at here, sometimes, like, if you want to make sure you're getting the whole curve, you could go to 4 pi, and that's actually giving us the curve twice. Okay, the next one is r squared equals negative sine t. Now, Desmos doesn't know what a graph in r and t is, so you have to switch the variable to theta for Desmos to know that you want a polar curve. That's one thing. The second thing is you have to solve for r explicitly. Desmos cannot graph r squared equals negative sine theta. It needs to graph each piece of the curve separately. So you have to solve this for r and write down two equations, plus or minus the square root of negative sine theta. So let's see what that looks like. Clear that one out. R equals square root, I think is SQRT. Yeah, square root of negative sine theta. Oh, need an equal there. All right, there we go. And then R equals negative the square root SQRT of negative sine theta. So this curve comes in two pieces. Top, well, this is actually the bottom, it's the blue curve, and then this part is the top. So it's great. You're not cheating by using Desmos. Use it for your homework. Use it and enjoy it. The only ones I want you to know how to do, by hand are the circles. All right, so in the next part of this video, we're going to talk about slopes and tangent lines.